Hello everyone. Today we'll talk about the solution to the problem flip columns for maximum number of equal rows. The first thing that we should notice is that when we have our matrix with the columns that we can flip, there is 2 to the number of columns ways of choosing the columns to flip. So that's a number that's infeasible to do anything with in the context of this problem. So we definitely cannot enumerate all the possible versions, but we would likely need a way to avoid even thinking about this whole big space of possibilities. And luckily, such a way exists. That's because our goal is to maximize the number of rows that have all values equal. And let's say that we take one row and we decide that this row should be a row where values are equal. Well, that row maybe has a 0 here, a 1 here, 1, 0, 0. Then how do we make this row all equal? Well, it's clear. We either flip all the zeros to ones and leave ones unchanged, or flip all the ones to zeros and leave zeros unchanged. So now, even though there are 2 to the width possible configurations, the only configurations that will even matter at all are configurations that make at least one row have all values equal, and every row provides 2 configurations corresponding to flipping zeros and flipping ones. We might also immediately at this point, since there is no difference whether we use one configuration or another, in other words, there is no difference if we make the row all equal to 1 or all equal to 0, we can imagine that we'll be flipping every row, let's say, to all zeros. So every row provides a single configuration. It doesn't change the final result. Okay, so what does that give us? Well, that lets us skip all the possible configurations of column flipping, and probably the easiest and the most intuitive way of now answering what the maximum number of rows is to notice that, okay, for every row we know the configuration that flips it. So if we count for every configuration how many rows it flips, so in other words, we maintain some counter, we add for every row the configuration that flips it, and we take the maximum cardinality element within that counter, this is the result. And we can actually do it exactly as I said, and this will be an acceptable solution. So we'll be maintaining a counter, and for every row, we'll have to create a key that will tell us the configuration that flips it, and increase the count of that key by 1. Of course, when building a string in Python, we typically build a list, and then we do empty string that join that list, that creates the immutable Python string. And now, we want for every element in our row to append either 1 or 0 to the string. And we also have to keep in mind that we only want the single configuration, so we'll remember if the first element is equal to 1 or not. And depending on if it's 1 or not, we either flip 1s to zeros or zeros to 1s. And we can use XOR to decide, because now flip XOR C will give us exactly 1 or 0 depending on the situation. Because we want if exactly one of those is true, is set, then we put 1, because we want to do, this is a 1 within the original string, we want to turn it into a 0, because the first element was a, well, if the first element is 0, this is a 1 we want to turn off. If the first element was a 1, this is a 0 that we want to turn on. And of course, if they are the same, then we put 0 in our key. And at the end, just the maximum of all the values is the final result. And the version below is almost the same, it just uses a different type of hashing, because here we create a string of length equal to the width of our array. And it's possible to do something better. It's possible through a technique called Zobrist hashing. And the technique is such that the final value is, as the word hash might suggest, a single integer. And we'll be maintaining that integer within the counts. Everything else remains the same, and the only question is how do we update this integer? And the idea of Zobrist hashing is that we, for every position, generate a random integer. And the final key, the final hash value, is just the XOR of all the values in key, corresponding to the positions where we want to flip the bit. Typically, Zobrist hashing is used because for XOR we can add elements, so we can essentially, when we flip a single value within a row or column, we can update the hash, because we just have to XOR out, or maybe we just have to XOR in the new value. So, and if we, let's say, turn this one off and turn this one on, we have to XOR again the value for this one, because XORing that value again will remove it from the hash and XOR in the value of the right one. So it's not necessary for us to use that, so we can use any type of hashing we want, but this is a pretty convenient way that uses random number generation. But anyways, instead of using the whole string, we can use any type of hashing. Zobrisk hashing is one approach that works in this problem.